Hey students, it's Mrs. Beamer here again, graphing in intercept forms. We're graphing quadratics. This is our third and final form, and it's actually a really great form because it's nice and easy to graph our intercepts with. It's y equals a. A tells us the same thing as before, times the quantity x minus p times the quantity x minus q. The problem with intercept form, the only problem with intercept form really, is that not all graphs have intercepts. It's y-intercepts here, not y-intercepts, silly me. X-intercepts. Let me rewrite this here. X-intercept form. If we had a graph way up here, well, it wouldn't have any x-intercepts, so we couldn't use this form. So that is the one problem with intercept form, is that you just can't always use it. So important thing here, our intercepts would be P, 0, and Q, 0. They are the x-intercepts. Now, just like when we have our vertex form, in our parentheses, it's x minus h, so then that becomes the opposite here. Notice we have a minus p and a minus q, so our intercepts are actually the opposite. They're actually, what would you plug in here for x that would make it 0? So for this, my intercepts are going to be a -3 and a +1 for this example right here. So I'm going to write that down here. So my intercepts are going to be -3, 0, and +1, 0. So the opposite of the signs. And I'm going to just plot them right here and plot them right here. Look how quick and easy it was to get those 2 points on my graph. Now, we know that parabolas have this axis of symmetry that cuts them right down the middle. So we know our axis of symmetry really should be right in the middle of these 2 points because they are at the same y value. So in a table they would have the same y values, they'd be the same distance from the middle. So to find our axis of symmetry, we actually find the average of our zeros. So our formula for the axis of symmetry is x equals p plus q divided by 2. That's the average. That's how you find the average of things. So if you just remember here, okay, my axis of symmetry is in the middle, so I'm averaging. So in this case, it's x equals -3 plus 1 divided by 2, which is -2 divided by 2, so it's x equals -1. And let's draw that in here. X equals -1 would be a vertical line right here. And yeah, look at that. That is right in the middle of my graph. So I drew my axis of symmetry next. Now, on a table here, I'm going to draw a couple things in here. My axis of symmetry, I know it's going to match the x value of my vertex there. So my vertex, let's plug that in next, finding our vertex. Our x value of our vertex is still the same as our axis of symmetry. And then just like with standard form, you're going to have to plug x into the equation in order to find the y. So we're going to have to take this -1 here and plug it into the equation to find our y. So you can do that in your calculator, or you can just write it down like I'm doing right here, because these are actually pretty easy to do. Just -1 there. So this is -2 times 2 times -2. So -2 times 2 is -4 times a -2 is a +8. So -1, 8 is our vertex. And again, you could plug that equation right there. You could plug this equation into your calculator to find it. You could also plug this into y equals in your graphing calculator, and that would help you as well since this is an exact value. Well, let's graph our -1, 8. So -1, 8, 1, 2, 3, 4, 5, 6, 7, 8 is way up here. So I really have 3 points on my table already. If I go up from -1, I'd have 0 and +1, and I know I have +1, 0. If I go down from -1, I would have -2 and -3, and I know -3, 0 was one of my zeros. So 3 points, real quick and easy. Now, here's the kicker. Our A does the same thing as before. So if I go 1 from the middle, I'm going to go down 2. 1 from the middle, down 2. So that will put me at 0, 6, and negative 2, 6. So look at that. Really super easy to graph these. There's my points. It's really super easy to graph this just by knowing what the equation told me. So again, to check this, you could plug it into y equals and double check our table to make sure it works. But our equation, we do the opposite of these numbers, and that tells us our zeros, our x-intercepts, or zeros. Those are two words for the same thing. We then do x equals, and we find the average of our zeros, and that tells us our axis of symmetry here. We plug the x value of our axis of symmetry into the equation, and that gives us our y value. And then if you're just missing points in the middle, use a to find them. Nice and easy to do that. So let's do a couple more examples. All right, so looking at my a value here, my a is negative 1, so I know my graph's going to open down. And the opposite of these are going to be my zeros. So negative 1 and positive 3 are my x-intercepts, or my zeros. Two words that mean the same thing there. So one of my zeros is going to be negative 1, 0, or my x-intercept. And then positive 3, 0 is my other x-intercept. So negative 1, 0 is right here. There's one x-intercept. Positive 3, 0 is right here. And again, our axis of symmetry has to go right in the middle, so we're going to find the average. Negative 1 plus 3 divided by 2, that's the average. So it's 2 divided by 2. So x equals 1 is my axis of symmetry. And I'm going to put that right in the middle. So x equals 1 right here. And yeah, it goes right in the middle. My two zeros, or my x-intercepts, I notice are both two places from the middle there. So my vertex is going to have this x coordinate, and I'm going to plug 1 into the equation to simplify. So my vertex is going to be 1, comma, let's plug a 1 into the equation. And again, you could use your graphing calculator to help you with this. So it's the opposite of 2 times negative 2, so that's ends up being positive 4. 2 times negative 2 is negative 4, with another negative becomes positive 4. So 1, 4. 1, 4 is way up here. And again, my a is a negative 1, so if I go 1 from the middle, go 1 from the middle, down 1. 1 from the middle, down 1. So I didn't even have to make a table for that one. It was pretty easy to do without a table. Connecting my points, yeah, that looks right. That looks like a nice parabola. And again, you could plug this, and to get a graphing calculator on the quiz, plug it in and check to make sure your points match up with what your graphing calculator says. All right, next one here, an a value of positive 4, so my graph's going to open up. I have zeros at positive 2 and negative 2, or x-intercepts at positive 2, 0, and negative 2, 0. Those are my ordered pairs. So looking there, right there, it looks like my axis of symmetry is at 0. And let's just double check that. X equals 2 plus negative 2 divided by 2. I'm averaging those at 0 divided by 2. Yeah, x equals 0. There's my axis of symmetry. It's the average of my x-intercepts. Oop, up above here, I forgot. I should have put my vertex on there. At that maximum, that's a 1, 4. Down here, my vertex is going to be at 0 for the x. And to find the y, I'm going to plug 0 into my equation. So 4 times 0 minus 2 times 0 plus 2. Again, use your calculator or just simplify it like I'm doing right here. So that is negative 8 times 2 is negative 16. Wow, that goes down quite a ways. So I'm going to change my graph. I'm going to change this, and I'm going to change my axes. I'm going to keep my x-axis at 1, but I'm going to change my y-axis to go by 4s. So it'd be negative 4, negative 8, and so forth. So my y-axis is going to go by 4s now, just because I need to be able to go down much lower on my graph, because I have 0, negative 16. So let's see here. There's negative 4, negative 12, 8, negative 12, negative 16, 0, negative 16 is way down here. Now my A value here, my A value is positive 4. So if I go 1 from the middle, I go up 4. 1 from the middle, up 4. So here's my A value. And again, look at, I didn't even need a table to graph these. Intercept form is a really quick, easy way to graph. It's just like I said, there's not always intercepts, so it doesn't always work. All right, just a couple more examples here. We're almost done. This one has a negative 2 for A, so I know it's going to open down with a stretch of 2. My x-intercepts are going to be the opposite of these, so negative 1 and negative 3. So negative 1, 0 and negative 3, 0. So that's going to be here and here. Now, it's pretty easy to find the average. It's going to be negative 2. But let's just do the math for it. Negative 1 plus negative 3 divided by 2. I'm averaging them because the middle is right in the middle of those. So x equals negative 2. That's exactly what I expected to see. All right, let me draw my axis of symmetry in there. So x equals negative 2. And my vertex is going to have an x value of negative 2. To find y, I'm going to plug that negative 2 into the equation. Again, this is still one that you could put into your graphing calculator and look at the table to help you. These are real quick and easy to graph without a calculator, though. So negative 2 times a negative 1 times a positive 1. And simplifying that, that's 2 times 1, which is 2. So I got negative 2, 2 as my vertex. So negative 2 and then up 2 is right here. And I'm just going to double check my A value here because that was 1 away from the middle. My A is negative 2. So from the middle, I go over 1, down 2. Over 1, down 2. Hey, perfect. Look at that. I need one more point here at 0 and another point here at x equals negative 4. So I'm just going to plug 0 in for these. That'll give me my last points. If I plug a 0 in, negative 2 times a 0 plus 1 times a 0 plus 3. That's negative 2 times 1 times 3. So I have got negative 6. So I've got that point 0. It will give me 0 because I plug 0 in for x, and negative 6 is my y. And that's going to be off the graph. It's going to be 1, 2, 3, 4, way down here. So you really don't have to put that on there since it's off the graph. I'm doing it because it looks nice. So there's my graph. Again, plug the equation in. You get to use a graphing calculator. Plug it into y equals. Double check that it matches the picture and then double check the table. All right, our last thing. We're going to be asked to change from intercept form to vertex form, from intercept and vertex into standard form. So we've got an intercept form here and a vertex form here, and we want to put them into standard form. So basically we're trying to simplify and get rid of our parentheses. There's 2 ways of doing this. For this first one, you could multiply these 2 together and then multiply the answer by 3, or you can just distribute the 3 to the first one and then multiply that by this. So I'm going to do that second method that I said. I'm going to distribute the 3, so I have 3x minus 12 times the quantity x plus 6. Distribute now, so multiply these together. So I have 3x squared, and then 3x times 6 is plus 18x. Then distribute here, negative 12x, and then negative 12 times 6 is minus 72. I now have 2 middle like terms, so I have 3x squared plus 6x minus 72, and it's y equals. So here is a hint to check to make sure that these 2 are equivalent. Put this into y equals, into your graphing calculator, and then put this into y equals as well. And then check the tables. The tables should be the same because these are just different forms of the same parabola. And that's how you check it. Next one, here we first have to follow our order of operations and do this x plus 4 squared. So I've got negative 1/2 times x plus 4 times x plus 4. We just can't give that squared sign to both. We have to actually use FOIL and multiply these out. So I'm going to multiply here and here first. So x squared plus 4x. Then here and here plus 4x plus 16. So that gives me x squared plus 8x plus 16. I still have that negative 1/2 in the front and the plus 5 at the back. So I followed the order of operations, got rid of my exponents. Now, next, I'm going to distribute here. There's some music from one of my kids. So I got negative 1/2 x squared. All right, sorry, a little pause there, and a little phone call. But where I was at here, negative 1/2 times x squared is negative 1/2 x squared. Negative 1/2 times 8x is going to be minus 4x. Negative 1/2 times 16 is minus 8. And then we still have that plus 5 hanging out at the back. And these are like terms, so I can combine them together. And I end up with f of x equals that negative 1/2 x squared minus 4x and then minus 3. So again, you're going to want to double check. The best way to double check to make sure you did it all right, plug this answer and this answer, plug both of these into y equals in your graphing calculator on separate lines. Let this be your first, your y1, your first graph, and this be your second graph, your y2. Check the graph, make sure you only see one graph because they're the same thing. Then check your table, make sure the tables match up exactly, but these are exactly the same graph. This is just in standard form, this is in vertex form. So that's how you check to make sure you did these problems right. Let's use your calculator to help you. Have a great day.